Welcome to Google Cloud Next. My name is Mehran Nazir. I am a product manager with Google Cloud. And today, I'll be speaking to you about how you can use BigQuery to transform your organization into a data-driven one. I'm joined by Fabrizio Blanco from Viant Technology, and he'll be going into Viant's journey to the cloud using BigQuery. So to kick things off, an exercise. Does anyone recognize what this number means? A hint, it's something that you would find in a school anywhere in the world. Exactly, I heard someone in the back saying that it's the Dewey Decimal System. Exactly what it is. So let's break that down bit by bit. The leading 0 is a classifier for information. The second 0 is for computing information, followed by data processing in computer science, networking, wide area networks, internet, and our final conclusion, data science on the Google Cloud Platform. The title, written by one of our esteemed training team members. Now, some of you, if you've walked into a library at any time in the past 10, 15 years, you might have recognized that. And for the most part, it's a useful system. It's a little bit subject to human error and some manual difficulties, but it is very important and powerful because it allows for people like you and me to navigate the treasure trove of information that a library is. And so that it doesn't belong to just subject domain experts like librarians. But we live in a different world today. We live in the world of big data. Estimates put the Library of Congress at anywhere between 15 to 20 terabytes of data. For a big data application, we can rack up 15 to 20 terabytes within days. In some applications, sometimes hours. And when you think about a library that doubles and triples in sizes overnight, you have a vast amount of problems. One, scaling infrastructure. It's not easy to find the space to house all those books and all that information. And related to that is finding the specific people that can manage that level of data. And to do both of those things while controlling costs is no trivial task. During my time on the Google Cloud customer team, I worked with many customers with various big data implementations. And what I realized was, while they would come to me very often with the technology problem, many times it was really a change management exercise that was required. And during my time, I'd see 3 main archetypes of a data-driven organization. One, you have the data-driven organization that is constantly pulled in different directions. This particular team is reactive. They don't necessarily have the proper data infrastructure. And they tend to be really just a supporter of the business intelligence organization. The second type is one that is fun, but not very productive. This tends to not have a very strong relationship with the engineering and product team, which allows them to have very limited product influence, and seems to be typically unfocused. The best kind of data science organization is one where data science are treated as thought leaders, ones where data contributions are recognized and celebrated. But most importantly, what I want you to take away from this is the fact that data is democratized, and they are investing in productivity. Importantly, when data is accessible and universally available to people within the organization, it makes that organization that much more tied to data, which, as we can all agree in this room, is typically a company's most important asset. Which transition to how do you do data infrastructure with GCP? We know that your data comes in all shapes and sizes. For your relational needs, we have Cloud SQL, we have Cloud Spanner. For your non-relational needs, we have Cloud Bigtable, Cloud Data Store for your document database needs. But what I'll be focusing on primarily today is BigQuery, the crown jewel of our data analytics platform. BigQuery is Google Cloud Platform's enterprise data warehouse solution, fully managed and serverless. If you're used to managing backups and working on disaster recovery plans with your data warehouse, you no longer have to worry about that because that is taken care of under the hood. If you need to run petabyte scale data and run queries across multiple tables, that can now return within mere seconds through a very convenient and intuitive SQL interface. If you need to scale up using CPU, RAM, and memory, no longer do you have to manage that. That is all, again, managed underneath the hood from the Google engineering team. And more, what we're seeing is our streaming capabilities coming to form in terms of streaming dashboards. But as we know, that technology is really just half the problem. The real problem is, again, people and change management. And when we look at enterprise users of data, we see them in multiple buckets. Small sliver being deep learning researchers, which number in the tens of thousands. Machine learning experts, which is in the low millions. Engineers, which is another order of magnitude higher, in the tens of millions. But the largest sliver of that are business users, business intelligence folks, finance, accounting, sales. All these people are the biggest consumers of data, yet if we don't have data accessible to them, that data is no longer an asset. So the question is, and the question I pose to you is, how do you turn technology not from a barrier into an enabler? And with that, I'll give it to Fabrizio to share Viant's story.
Thank you, everyone, for coming. Let me jump into the presentation. So what is Viant? Viant is an advertising technology company that delivers the right audiences across all inventory formats and channels, and it's capable of measuring its impact online and offline. The main piece of technology we use to do that is the DSP, which stands for Demand-Side Platform. Since I'm going to be talking about all the data that flows into the DSP, I may as well give you a quick primer about real-time bidding and the technology behind it. On this picture, you see two sides, the demand side and the supply side. The demand side is the advertising technology ecosystem the advertisers use to help them spend media dollar or to buy inventory online. And the main piece of technology they use is DSP. We have one of those. On the left side, you have the supply side, which is a technology ecosystem that publishers use to monetize their audiences or sell inventory online. And the main piece of technology they use is the SSP, which stands for Supply Side Platform. The way advertisers buy media online in real time is via RTB protocol, and that's how the SSP and DSP communicate to each other. To give you an example, a user comes to a publisher could be an app, a website, a video channel, audio channel, anything you can imagine. The goal of the publisher is to maximize the revenue out of this opportunity. The way they do that is by auctioning off this opportunity to multiple buyers at the same time, and that's where they use the SSP. The SSP is connected to multiple DSP at the same time. The DSP will just leverage the data they know about the user to decide if they're willing to bid or not, if they're willing to bid or much they're willing to bid, and then if they win the auction, that's called an ad impression, and the advertiser gets to display the ad on the publisher. That happens billions and billions of times a day and generates a lot of data. Each single auction needs to be closed within 50 to 100 milliseconds. We're talking about very complex ad stack and a lot of data. What does it look in terms of data for Viant DSP? We process more than 100 billion events on a daily basis. Those events represent more than 100 terabytes of data. On a second, we process more than 1 million events, and each single event has more than 700 data points. So when I talk about events, I'm talking about this RTB request, bid solicitation, as well as impression, clicks, conversion, anything you can do with ads. And how did we manage to do that before BigQuery? I'm talking about before 2014. So on the left side, we had a custom ingest problem. We ingest all this row-level data into Hadoop. It is, when it was entering inside Hadoop, we say enter the data warehouse ecosystem. The data, by the way, there's a gray box. You can see there. The data warehouse ecosystem. And the way the data warehouse ecosystem was managed by the data warehouse team, and that was a handful of people that was servicing the entire organization for any data needs. And the way they were processing the data was through MapReduce, Pig and Hive on top of Hadoop. And the canned data marts typically out of this process will be pushed into Netezza, which is a physical MPP appliance which you can query via SQL interface. And the way the business would access the data was through a business intelligence tool, Tableau, pointing to these canned data marts. Anything outside those canned data marts will need to go through a process of vetting, prioritization. So although this picture looks pretty nice and looks like everything should be working, the reality is if I have to reflect what was happening at the time, everything should have been on flame and melting. And the reason was we actually have a very hard time keeping up with the scale of the business. Every day, more and more data coming in, and more requests coming in. And there are two sides here on the scaling issue, one on the Hadoop side and the Netezza side. The Hadoop side, although relatively easily, we could scale it by adding machine and storage. The business was unpredictable. It was very hard to predict what was going on tomorrow, next week, next year. And so we were struggling and compromising between CPU and storage constantly. And of course, spending time keeping the cluster up. On the Netezza side, it was much harder to scale. You just have to double up on the cluster, and we're talking about millions of dollars of investment. Needless to say, the data warehouse team, instead of being an enabler to the organization, not because of their fault, was actually a disabling factor. And the reason was 80% of their time was spent maintaining infrastructure, maintaining the cluster, making sure the existing pipeline wouldn't break. So long story short, late 2013, beginning of 2014, we started looking at alternatives. We did a bunch of POCs, and BigQuery was the big winner for us by far. We moved every single piece of data into it. We never looked back. It was the best decision we ever made. The reason we picked BigQuery is twofold. Number one, it is a serverless infrastructure, meaning it is a service to us. We don't need to worry about scaling. We don't need to worry about tuning. The second big reason is you could query hundreds of terabytes of data within seconds and minutes, versus before it would have taken hours and days if the query ever came back to start with. So how does the architecture look like now that we have BigQuery? Very much simplified compared to before. Still, we have a custom ingest problem that pushed the raw-level data into BigQuery. The data warehouse ecosystem right now, it's only BigQuery. Every single piece of data is inside BigQuery. The data warehouse team will process the data by leveraging all the API available from BigQuery to process and produce the same canned data marts we used to produce before, and we're pushed into BigQuery. And the way the business would access data was through Tableau, pointed to BigQuery this time. And then another thing that we did, we gave access to the user using BigQuery native UI. By giving access to raw-level data to a bunch of people with SQL knowledge, what happened is the amount of requests that came to the data warehouse team and data engineering team skyrocketed because all these people finally saw the richness of the data that we had, and they never had access to it. All of a sudden, they start dreaming about these data products, all this stuff they wanted to build. And long story short, we removed completely the bottleneck of our infrastructure with BigQuery, but a new bottleneck was created, which was engineering resources. Because we have this unbelievable race car, which was BigQuery, and only a few people could drive it to its potential, and those were people with engineering skills. That's when we decided to build a couple of tools, Magnus and Goliath, with the goal of empowering as many people as possible within the organization to basically be a data engineer like anybody else with engineering skills, but without, of course, just with SQL knowledge, they could do everything on their own without involving anybody else. And that's where Magnus and Goliath were born in 2015 and now available on Google Marketplace as of 2018. I'm going to give you a quick demo, but before I do that, the new architecture looks very similar than before. There are two main differences. Number one, Potence.io tools on top of BigQuery are now used for processing and accessing the data. Another big difference, a little subtle here, you don't see it, but if you remember the previous two diagram, there was this gray box data warehouse. That's gone. And the reason it's gone is because twofold. The data warehouse engineers, first of all, their job description is changed, and now our software engineer building the Potence tool. This team is not servicing the organization in terms of data needs anymore. Second is we actually fully decentralized our data warehouse, and there is no central point where requests come in. Everybody can do everything they want around data as long as they have permission on a specific data set. And now I'm going to jump into the demo. Demo number one. On this demo, right now I'm an analyst. I work for the client services team, and my clients, the DSP clients, are the advertiser. These advertisers have been asking to get their data back on a daily basis or whatever, basically their impression logs back. And the reason is they use multiple platforms and want to aggregate everything in one place. And for that, I decided to use Magnus because I'm very familiar with Magnus, which is our workflow automator. And I want to make it such a way that it's generic, such that I can use, if a new client comes in tomorrow and wants the same thing, I shouldn't be able to change anything, and the workflow should just run. Before I jump into the automation part of it, I want to show you what the data set looks like. And for that, I'm using Goliath, which is our data explorer, the tool that you use to explore your data sets, be able to query and interact with the data. Specifically here, I'm going to, the data set I'm talking about is the ad impression data set. This is an actual sample of actual data. So we're talking about 28 terabytes of data right now, 4.3 billion rows in total. You can see quickly, double-clicking here, I have a sense of all the tables in here. I can sort. I can see the size of each specific table, the size. And then if I click on it, I can see that Goliath does a very nice job on grouping logically the data by year, month, and day. I can mouse over a specific day. I see exactly the size of this table. If I click, I can see the scheme of my table. And like I mentioned before, we have this more than 700 data points per single event. An impression is an event. And I can show you here, if I expand my list, you can see that we have all these 700. Those are basically all columns in our table. And for us, it was very important to see that organized the way we actually store the data, which is objects within objects. Another thing that was important for us as well is to actually see what the content looks like for anyone that is trying to work on queries around the data. So we wanted to represent the data as objects as well, the moment you preview or you query the data. As you can see here, I can go across my columns and see the content and have quickly a glance of what each single field value could be like. And specifically now, since I'm going to be talking about extracting log from the impression tables, one important field I'm going to be needing is the advertiser ID, which is the one I'm going to apply the filter for that query. And since I said I want to make this thing very generic, what I'm doing is creating a table called advertiser to extract. On this advertiser to extract has two columns. Number one is telling me all the advertiser ID they need the data back, which is the first column. The second column is telling me, well, definitely all advertisers, they don't want the 700 data points that we have. They just want to pick and choose whatever fields they want from the table. And here I'm describing what they are. And now I'm going to jump into Magnus, which is how I'm going to create this workflow to automate this extraction. So the first workflow is called parallel extract. And before jumping into specific of the workflow, you can see on the top the name of the workflow, the description, the owner. I can set up a lifetime of a workflow. And more importantly, I can schedule it as a cron, fixed or advanced as a cron job. And then you can specify a time zone as well for this specific workflow. On the right, you'll see a very important element here, which are what we call parameters. And parameters are two kinds, built-in and custom. Built-in is things that the system generates for you, Magnus generates for you, are typically time and date-based. And custom is anything you want to create. Think about variable and constant in your programming language that you use to make your content dynamic and create business logic around it. I'm going to show you how I use these parameters. So the first task I'm using right now, by the way, you can create several tasks, and you put them sequentially, and that describes the workflow. My first task is a loop task. As a loop task, it requires an input a table. This table, I'm referencing it via this variable, and this variable is the table I just showed you before, and which was a true potence, which is one that describes the advertiser ID and the fields. And then it needs a parameter, which is called, in this case, advertiser, which is going to iterate over and pull a row per table. Every time I iterate this table, I'm going to pull a row. And this record this variable is of type record. And you can see here the way it looks. It's basically the scheme of the table, advertiser ID, and the string, which is the field. Another thing inside this loop, I have only one task, which is a BigQuery task. And what this thing does is just running a query. But as you can see, there are dynamic elements inside the query, which is the table itself I want to extract the data from. I'm using this variable. Then the filter itself, which is the first element of the record, which represent the advertiser ID. And this is the fields that they need out of this specific query. And then another thing I wanted to do is make the output of the table generic. I want to postfix the tables with the advertiser ID and the data I'm processing with. Another thing that was very important for my client is to get the data as soon as possible. So what I wanted to do is, typically you have a workflow that runs sequentially, and sequentially because a specific task depends on the previous task. Well, in this specific case, I really don't need things sequentially because every single query is independent of each other. Through Magnus, I can simply say, run this asynchronously and make them all run at the same time to maximize time. And then at the end of the loop task, I just simply wait for all of them to finish. I can set up a timeout. I can get a notification in case there was any error. So now I'm going to run this query, this workflow by hand. And the output of this table should be, will show up inside this data set. Right now it's to still be empty. And while this workflow is running, I want to show you how you actually check what's going on. You look at the workflow history, specifically for this workflow, you can see it is still running. The previous execution actually finished. So I'm clicking on this one, and you can see that the 10 iteration got submitted. The loop task finished in 14 seconds. All 10 queries got submitted. I can drill down on any query and see what was the query that got submitted. You see the macros got expanded for me. You can see as well how much data is scanning that specific query, and you can check every single one of them. And then at the end, you see there is the wait task is waiting for all of them to finish. And let's see if now it's finished. So it's not finished yet, but the tables to start showing up here. And actually, all of them are finished now. You can see the 10 advertisers are all done. And if I click on here to see if it did what it was supposed to do, well, for advertiser 3312, you need the XID, timestamp, request URL, and meta. All of them work properly. One thing I want to point out, OK, I'm done with this specific demo. But one thing is, it was relatively simple to build with Magnus, just 3 steps, really 3 tasks. But if I had to do this outside of Magnus, I would have needed to ask an engineer to build this software around it, create a bunch of threads, push a bunch of jobs out, wait for them to finish in another thread, and then ask system engineers to have a machine to run this thing on, a cron job, worry about all this monitoring, all of that, it is completely gone with Magnus. We don't need to worry about any of that. It's just managed transparently. It's a service on top of a service, which is BigQuery. So next example. Next example is going to be a little more sophisticated example. In this case, I want to showcase how you can connect Magnus with other systems via an API task. Because Magnus can be initiated via manually or through a cron job. It can be called via API. We can trigger an execution of Magnus with a bunch of GCP events. But how do you connect Magnus with external system? Let's say with other GCP API or your internal API. Well, we have an API task. Of course, with the API task, the world of opportunity opens up. And specifically now, I am a product manager. I work for the DSP. And I have my advertiser have been telling me lately that it takes too long for my images creatives to be approved. And the reason it takes too long is because we have humans involved that check physically if the image violates our content policy. And as a product manager, I have the idea, well, I know how to improve this. I would like to have my engineers build this thing, but engineers are always busy, so I decided to take it on my own. And the reason I decided to take it on my own because I'm familiar with Magnus, and also I see that Magnus has this API task, and a bunch of templates are available to make it very easy to connect to any API from the GCP ecosystem, including Dataflow, PubSub, Google Cloud Storage, machine learning, which is I'm going to show you right now, etc. So it's very, very easy, and you don't need to worry about authorization authentication because the token gets passed automatically by Magnus. So at that point, I decided, OK, it's cool. I can do it. I did some research on Google Vision API, and I see they have a specific API, which is exactly what I need, which is Annotation API with a safe search detection type of annotation that takes in input an image and gives me back if the image contains adult content, violent content, racy content, medical content. It's exactly what I need. So what I'm going to do is just build this Magnus workflow, which is annotate new creatives demo. Since it's a little more complex compared to the previous one, I'm going to give you a view because one of the tasks, for instance, I'm using here is calling a workflow. So you can modularize your code and create a bunch of tasks within a workflow and then make other people use it. In this case, to show you the entire view of what's going on here, I'm showing you the 3 view. 1,000 feet level, these are the name of the task. You can drill in on each one of them. So what this process will do is just check if on the creative table there are any new creatives been pushed. If there are any new creative, I'm going to call the classify as workflow. If not, I'm done. There is no new creative to process, so I've finished. The classify as workflow, what it does is loops and batches the creative in input, just to make sure I don't want to call one at a time. I just want to batch as many as the API allows me. And then creates the payload with this generate payload. Basically, the API requires a JSON payload. I'm using BigQuery to generate this payload, pass it to the API task, and then take the result back. And on the calling workflow, I'm checking here if there was any creative that got flagged. If there were any creative that got flagged, I send an email out. So I'm going to execute this, and I should be receiving an email shortly. But while this thing is executing, I'm going to give you a little more insight into the workflow. So the first workflow is what I just described before. I'm checking if there are any new creative to process. And the way I'm doing this is by leveraging the fact that parameters are actually persisted for Magnus. So I'm using the result of the previous execution to check what was my last ID that got processed. And then I'm just using it as a parameter here on this queries. I take every new creative since the last creative ID, take the output and put it on this table. This table is described here. Creatives out input. Then what I do is count the number of rows out of this query, which is specifically count the rows on this table, and assign it to this variable, which is new rows. And then this is the if-then condition. I check if there are any new rows. If it's greater than 0, pretty much, go to the next task, otherwise finish, because they have nothing else to do. The next, by the way, this flashing means the workflow finished. I'll show you the email soon. The next workflow, which actually does the job of classifying the ads, is this classify ads workflow. Workflow take inputs, and those are basically are the parameters for that workflow, which is the destination table where this annotation needs to be stored, the source table, the input to my API, where are all this creative I need to check, the batch size, as well as the type of annotation that I need to call the Google Vision API with. And then I'm basically storing my ID for the next iteration, so I remember where to start next time. And here I'm checking if any creative got flagged with a SQL query. Let me go back here, and I should have received the email. OK, this is the new email that just got sent. As you can see, it's basically an HTML table with the first is the ID of the creative. The second is the image that got annotated. And as you can see here, these 3 images have a medical annotation type of, there's a possibility there is medical content inside this image, and the same thing for all 3 of them. So it worked, meaning it's able to detect there were 3 creative possible medical content. By the way, for the purpose of the demo, I just disabled the check across adult content and stuff, just to avoid showing something on the screen that was not appropriate. As you can see here, you see the lines I commented out. And this is just running the query and generating a little HTML table that I'm sending via email here. And here the email task, I'm simply say, OK, format it as HTML. This is the header of the table, and these are the 3 rows you just saw with this variable, which is being computed by this query. And now I'm going to show you by clicking here what exactly those queries returned. If I run this query, you'll see that the 3 rows were these ones. It's basically I'm showing an image and the content. And as you can see, this query shouldn't run because there are these variables in here. But guess what? When I click from Magnus and jump into Goliath, all parameters that I need to be able to execute the query are being brought over. And I can show you the used ones for this specific query were those ones. So I'm able to debug specific query the way they are without changing them. So said that, I want to show you how I generate the payload from the classify as internal workflow. This is the execution of the classify as. So I was batching the creative. Basically, I'm using the limit and the offset of the creative to batch through a bunch of creatives. And then I'm basically generating the payload via a query. You'll see what this query is. This query is it looks complicated, but it's basically I'm generating a JSON object out of 3 rows on a table. And I can cut and paste this so you'll see what the output of this query is. This is the output of this table. It's basically created a payload for my API, which is a JSON representation of the images. And then, if I look here, the next task that got executed is the call of the Annotation API. What I passed in input is this JSON that I prepared with the previous queries, and that's the output back. So for each creative, it's telling me the probability of each type of content. And then the next task, I'm using JavaScript task to, it's hard to see, sorry, to populate the table itself and take the result back. So this, again, is to showcase a little more complex use case to be able to connect with several APIs, but you can have microservices internal to you, and you can do a similar thing. One thing I want to show you is now, can you bring it back to the presentation, please? To the slides? Yes. How do we use, what are the stats of potence within Viant? Viant is not the only customer. Viant builds potence, but we have multiple customers of potence. Those are stats only within Viant itself. Till today, we have about 360 users using the platform. And by the way, we don't have that many engineers. It's all BI team, research analytic team, product people, anyone you can imagine using the tool. Those people generated 5,000 workflow. Total number of tasks across all workflow is 180,000. You can see somebody went crazy and built a workflow with 3,200 tasks in it. So it must have been something complex. But the average is about 36. Probably the median is much smaller than that. And then this is a current month, the way potence is used. 130 users used Magnus. Those 130 users generated 600,000 workflow executions. This workflow execution generated 2 million queries into BigQuery. And this 2 million query processed 16 petabytes of data. That's on a normal month that was last month. If you're wondering how tasks are used within Magnus, well, BigQuery, to no surprise, is the favorite task because that's the workhorse where all the things happening. The big data crunching is happening through BigQuery. The next most popular task is go-to task. That makes sense because you do business logic through that if the if-then-else conditions. The workflow tasks is very much used as well. And that's because you want to modularize your workflows. You can have people build something a little more complex, like, for instance, this classify as. And you, as a user, you can leverage it by calling it as a library. Then the API task is just to connect with other systems. And then the script task to manipulate data and the email, although it's a small percent, but it's very much used. But of course, you have one email probably per workflow. So that's why it's only 1%. And that's it for the presentation. Just go ahead and try it, Potence.io. It is, you're going to get unlimited use of Goliath and a trial of Magnus. We love it. Our customers love it. And it changed our life. Before, we had a handful of people be able to do complex things with data. Now you have hundreds of people within an organization that can do as much as data engineers or data warehouse engineers could do without involving people with engineering skills. Thank you. I'll get back to Mehran.
Thank you, Fabrizio. A round of applause. That was a live demo. I was actually watching him. He did hit refresh button a couple times. My heart was racing. That was probably the most exciting thing I'll see at a cloud conference. But with that, I wanted to highlight, more seriously speaking, I wanted to highlight 3 big things that Viant did in this particular scenario. One, in the first slide, they showed that they had a very, very extended cloud footprint. And they said, we no longer want to manage infrastructure. That was the first step, to no longer manage that headache. 2, they created an interface to make data accessible to their entire organization. One of the more powerful insights from that presentation was that it no longer belonged to data scientists. It belonged to business users. It belonged to all kinds of people that no longer needed to work with the data scientist. And then 3, they're able to extend the power of BigQuery with the rest of the Google Cloud Platform. The most powerful thing about that second demo was that it was now using the machine learning APIs to basically generate metadata to associate with creatives. Instead of having to create a completely different workflow and a completely different application for customers to access another part of the Google Cloud ecosystem, this particular tool they built was built all on top of that. And when I've seen successful data companies, it's companies that really bring the power of different cloud technologies all together in one place. So to summarize, BigQuery doesn't have to be exclusively used by your data teams. Again, to think that it is, and it's only in the domain of data scientists, would be very short-sighted. The real power is when you unlock that power for the rest of the organization. When you create tools like Magnus, or build your own tools, or work with other partners. And then lastly, BigQuery is a flexible and extensible platform, one that allows you to basically take its compute power and apply it in many different scenarios. I don't know if you guys were paying attention to the specific numbers that were being generated, but in the first demo, I saw that one iteration was going through 300 gigabytes within 10-15 seconds. And there was 10 queries being run in parallel. That's about 3 terabytes. And again, that that processing time doesn't scale linearly. It goes exponentially faster. And that is a very powerful insight to take away to help BigQuery become the center point of your data-driven organization. To summarize, I wanted to also just kind of point you guys to other really interesting presentations. We have a number of customers that will be presenting their stories with BigQuery and showing how they use the power of it to enable their organizations. But a special focus on the top line. We have a spotlight session at 2:10 tomorrow afternoon. This is where we will be announcing all of the new magics with BigQuery and also across all our entire data analytics platform, from Dataflow to PubSub to other new products that we'll be announcing. I'm not allowed to say anything about it today, or else I'm going to lose my job. But would like invite you guys to see that tomorrow.